In this lesson, we want to take a look at developing the form of the equation of a circle. Notice in the figure I have a circle whose center has coordinates h, k with a radius of r, and the point xy lies on the exterior of the circle. Notice in my picture that if you draw the triangle here, going from the center hk to this point xy, with a radius of r, you are drawing a natural right triangle where this point would actually be x comma k, and this length along the base of the triangle would be the change in x, and this vertical length would be the change in y. And you can notice I've made the statement that the change in x is x coordinate minus x coordinate here, and the change in y is corresponding y coordinate subtracted. Okay, and it's a nice Pythagorean theorem application because we have basically the leg squared plus the leg squared equals the hypotenuse squared, or the change in x squared plus the change in y squared is the square of the radius, which would then lead us to x minus the x coordinate of the center quantity squared plus y minus the y coordinate of the center quantity squared is the square of the radius of the circle. And this is a perfectly great form that we call standard form. Some people call it center radius form because, again, you can pick out the center and you can pick out the radius from the form of the equation. Okay, let's take a look at an actual question. It says determine the radius and the center of the circle with equation x minus 8 quantity squared plus y minus 2 quantity squared equals 43, and then determine whether the point 68 is on the circle. Provide exact expressions, not decimal approximations. Now, recalling what we had in the last little bit of this video, we know that the standard form of the equation of a circle looks like x minus h squared plus y minus k squared equals r squared, where h and k are in the position of the center. The minus signs are built in. So notice here our change in x leads us to a center having an x coordinate of 8, and our change in y gives us a y coordinate of 2. This is the square of the radius, so the radius itself would be the square root of 43. So we enter our ordered pair. We already have parentheses given to us so we don't retype them. And then we enter our radius exactly in its symbolic form, square root of 43. Now, to check to see if the point 68 is on the circle, then you just need to substitute into the equation x is 6, y is 8, and we're going to find out whether or not it's equal to 43. Okay, so doing the calculations here, we'd have negative 2 squared plus 6 squared, so we'd have 4 plus 36, which is 40, which is not 43. So this point is not on our circle. Okay. Now, another just side comment, because 40 is less than 43, the point 68 actually lies inside the circle, in the interior of the circle. If this value were bigger than 43, it would lie outside the circle. Okay, one more circle application. Find the equation of the circle that has center 6, negative 3 and radius 2. And we're going to go back and every single time review the basics. We have standard form, and it is x minus the x coordinate of your center squared plus y minus the y coordinate of the center squared equals the square of the radius. and we end up with x minus 6 quantity squared plus y plus 3 quantity squared equals 4, being a nice form of the equation of the circle with center 6, -3 and radius 2.